Okay, so we're going to do a brief introduction to complex numbers. So remember, complex numbers have that I value, but in particular, complex numbers are of the form a plus bi, where a and b are real numbers. So you can have a complex number that looks like 2 plus 3i, or pi plus root 2i, and so forth. These are all complex. And the ones that we're going to be talking about in particular right now is about the degrees or exponents of complex numbers. So I, remember, if it has a power of 1, is just itself. But I squared, the way we evaluate that is by converting I back to its square root form, which is the square root of -1. The square root of -1 squared is -1. And then again, I cubed. Well, that one is I squared, which is the one above it, times I. So this is -1 times I. I4, again, gives you just 1, because this is going to be -1, that's going to be -1, and their product is going to be positive 1. But notice once we hit here, this is the same as that, and the -1 here is the same as that one. So it cycles between these 4 possible options. I, -1, -I, and then 1. And then it goes back to I, -1, -I, and then 1 again. So what we're going to do, though, is instead of using this property, which you can do, which is a little trick with division by 4, you can do it that way. But it then requires you to memorize the order of this table. So instead what we're going to do is we're going to just use our exponent rules, and everything will come out. So let me go ahead and erase this, and we can start working on these problems. So over here, what you're going to do is you're going to use the fact that we know that the I value is the square root of -1, and that the square root of -1 squared is -1. So what we want to do is find a way to write these as squares. So I to the 36 can be rewritten as I squared raised to the 18th power. Because when you raise exponents to exponents, they multiply. So we can rewrite that 36th exponent as 2 raised to the 18th power. This, though, I squared, is this one. So that is just -1. Well, a negative number raised to an even exponent is positive. So this is just the number 1. This one, what you do is you're going to first convert an odd number, and what you're going to do is you're going to split it into an even number at 1. So I to the 58th times I. Because when you multiply with the same base, you add the exponents, right? So using your exponent rules. This here is now even. So we can go back and use the same property that we did here to convert it into I squared raised to the 29th power times I. Because that's going to be 58. The inside I squared, again, is -1 to the 29th power, and a negative number raised to an odd exponent is going to be negative. So this is going to be just -I. So being able to write out these I values raised to exponents is fairly straightforward just using your exponent rules. The other things that we want to do with these complex numbers is be able to solve them using our original algebraic operations like addition, subtraction, multiplication, and division. So addition and subtraction have the same rule. What you do to solve these is you combine like terms, right? Just think of I like a variable. So here we have a complex number, which is -12 minus 3i, and we have another complex number, which is -2 minus 8i. So first, we do this distribution, and then we move it around so that the like terms are next to each other. So -12 plus 2 minus 3i plus 8i. So these are like terms, and these are like terms. So what we get down here is going to be 5i, and what we get for the other one is minus 10. And that is how you add and subtract complex numbers. Very straightforward, no different than if you had an x there. Multiplication, exact same thing, do the distribution. The only part that changes is when you have I to a power. But we already know how to deal with i's to powers, so let's go ahead and see what happens. So the first one here is 15. The second one is negative 21i. That one is going to be minus 25i. And then lastly, plus 35i squared. Combine the like terms to get minus 46i. We have the 15 here, but the one on the right-hand side, this I squared, remember, I squared is equal to negative 1. So that's just a negative 1. So all we need to do is change the sign in the front to minus 35. And then again, now we have another two like terms, these two. So we can go ahead and simplify that one as well. So we get right here, which is going to be negative 20 minus 46i. Now one thing to note, remember complex numbers are written in the form a plus bi, and with a plus or minus in the front either way. But you have to write it in that form. So in other words, you can't have this 46i in the front. It should be written as a plus or minus bi. The last one. The last one is the most complicated out of the things that we've done. But really all it is going to do is it's going to convert it into a multiplication problem. And what you need to do to get rid of the I in the bottom, because what we're trying to do again is write it in the form a plus bi. And we can't do that necessarily here because of that division and that plus or minus in the bottom, right? They don't split like we would if we had only a single term in the denominator. So what we're going to do is we're going to use a trick that we have before. We're going to multiply by the conjugate. So the conjugate on the bottom is going to be 10, negative 10 plus 3i. And anything you do to the bottom, you do to the top. So the numerator, when we multiply that out, it's going to be 30 minus 9i. And the next one here is going to be plus 20i. And then the last one is going to be minus 6i squared. Oops, sorry. The denominator is going to give you 100 minus 30i. Then the next one over here is going to give you plus 30i. And then the last one is going to give you 9i squared, minus 9i squared. Now, if you want, remember, what we really have there is negative 10 minus 3i times negative 10 plus 3i. So that's a difference of squares, right? And we've already done that based on the conjugate, that this is going to be negative 10 all squared minus 3i all squared. And what you can see here is that we'll get the same thing, right? Because the bottom is going to be 100, these cancel, minus 9i squared, which is 100 minus 9i squared. Simplify the top to get 30 plus 11i. This one over here is minus 6i squared. And then use the fact again that we know that I squared is negative 1. So both of these would change the signs which is attached to their constants. So this is 30 plus 11i plus 6 all over 100 plus 9. Okay. Simplify that as 36 plus 11i, all divided by 109. Now don't forget, our goal was to write it as a plus bi. So we need to write that by distributing the 109, the division by 109 to both parts. So this is 36 divided by 109 plus 11 over 109i, where this is a and that part is b.